Welcome to this session on AI-powered security tools, redefining cyber defense, brought to you by BlueHat CyberSec Academy. Today we'll explore how artificial intelligence is transforming cybersecurity, not as a futuristic concept, but as a real operational capability used by organizations worldwide. Over the next few minutes, we'll cover key technologies, real-world examples, challenges, and the strategic future of AI in security operations. Let's start with the big picture. Cyber attacks are no longer occasional, they're constant. A University of Maryland study found that a cyber attack happens every 39 seconds on average. Gartner reports that AI-driven phishing and social engineering attacks have increased by 38% year over year. Meanwhile, SOC teams face alert fatigue, burnout, and a global skills shortage. The conclusion is simple. Traditional, manual defenses can't keep pace with the speed and scale of modern threats. We need automation and intelligence, and that's where AI comes in. Historically, security has been reactive. We waited for attacks, identified patterns, and wrote signatures or rules. But adversaries innovate faster than rules can be updated. AI flips the model from reactive to predictive. It learns from patterns of behavior and can identify potential threats before they cause harm. As Bruce Schneier famously said, AI changes the speed of both attack and defense. The new race isn't just about patching vulnerabilities, it's about who can analyze and adapt faster. In simple terms, AI in cybersecurity refers to systems that can learn from data to identify, predict, and respond to cyber threats. It uses machine learning and deep learning algorithms to detect anomalies in user, network, or system behavior. The process looks like this. Data is collected from sensors and logs, then models analyze it, and the system infers whether activity is normal or malicious, and finally, it triggers a response. This dynamic loop allows continuous learning far beyond static rules. AI security tools typically rely on three machine learning paradigms. Supervised learning is trained with labeled data, such as known malware or phishing examples. Unsupervised learning, on the other hand, explores unlabeled data to detect unknown or emerging threats. And then there's reinforcement learning, which continuously improves models based on outcomes and analyst feedback. The challenge really lies in balancing accuracy and interpretability. As models become more complex, they can become black boxes, which raises accountability concerns in enterprise use. A robust AI security system is built on three layers. First, there's a data ingestion layer that gathers logs from endpoints, networks, and applications. Second, an analysis layer extracts features and scores behavior. And third, an automation layer, often integrated with SOAR platforms, executes playbooks for containment and remediation. Above all, a human-in-the-loop process ensures that model outcomes are validated, and retraining happens continuously. The AI lifecycle in security is essentially a continuous feedback loop. It begins with collecting data, then training models to recognize patterns. During operation, models detect anomalies, trigger alerts, and learn from confirmed cases. Analyst feedback is crucial. Verified outcomes are fed back into the system for retraining. This really aligns perfectly with the NIST SP 1270 guidelines for trustworthy and continuously improving AI systems. The AI-powered security ecosystem includes several tool categories. Endpoint detection and response tools, like CrowdStrike and SentinelOne, analyze process behavior and detect unknown malware. Network detection and response tools, such as Darktrace, use unsupervised learning to identify abnormal network patterns. Email and phishing AI tools analyze linguistic and behavioral cues to stop social engineering. Cloud Security Posture Management, or CSPM, monitors API calls for privilege escalation or misconfiguration. SOAR platforms automate incident responses through playbooks. Together, These create a layered, adaptive defense. Let's look deeper into endpoint and network defense. Machine learning models analyze endpoint telemetry, things like process chains, registry changes, or file creation events, to identify suspicious behavior. Similarly, network AI monitors traffic flows and can detect lateral movement or data exfiltration. CrowdStrike, for example, has reported cases where ransomware was stopped mid-execution through behavior correlation rather than signatures. Cloud and email systems are among the top attack vectors. AI systems here monitor massive API traffic volumes, looking for anomalies such as sudden privilege elevation or configuration drift. On the email side, NLP-based models read content, tone, metadata, and behavioral patterns to catch spear phishing attempts. Google's AI filters block over 100 million phishing emails daily, a clear example of AI's scale advantage. Security orchestration, automation, and response, or SOAR, is where AI meets action. These platforms integrate with detection systems and automatically run containment steps, such as isolating infected endpoints or blocking IPs. Analysts no longer waste hours on repetitive triage. Industry reports show that SOAR can reduce mean time to respond by more than 60%. The result? Faster recovery, less damage, and higher team morale. The latest frontier is generative AI in the Security Operations Center. Large language models can, summarize complex alerts, draft incident reports, or even suggest remediation commands. Analysts can query data conversationally, asking things like, "Show me all endpoints with suspicious PowerShell usage." Gartner predicts that by the end of 2025, over 60% of SOC teams will use generative AI interfaces. But of course, governance and validation remain essential to prevent AI hallucinations or false remediation. A financial institution using Darktrace detected an insider threat before data exfiltration occurred. Behavioral analytics flagged abnormal access patterns. An employee downloading files at odd hours. The system autonomously contained the session, alerting security for manual review. Forrester's 2024 study estimated a 45% reduction in incident costs for organizations implementing similar AI-driven behavioral tools. In another example, an enterprise using CrowdStrike's EDR solution identified a new ransomware variant. The AI model correlated process trees in real time, detecting a malicious encryption chain. The attack was neutralized before encryption began. The takeaway here is that explainable AI improves analyst trust and adoption. Transparency in model reasoning is absolutely critical. AI offers 4 major benefits. First, scale. It processes billions of signals per second. Second, speed. It reduces detection time from days to minutes. Third, adaptability. Models evolve with new threat patterns. And fourth, efficiency. Analysts can focus on high-value work. In essence, AI is the force multiplier the security industry has long needed. However, AI is not a silver bullet. False positives can, really overwhelm analysts if models are poorly tuned. Data poisoning, where attackers insert malicious examples during training, can actually blind AI systems. Regulatory concerns such as GDPR and AI Act compliance require explainability and data integrity. And finally, human oversight remains non-negotiable. As defenders adopt AI, so do attackers. Adversaries use AI to automate malware mutation, craft deepfake phishing, and even generate polymorphic payloads. On the defensive side, adversarial ML attacks can trick models into misclassification. Following the NIST AI risk management framework, organizations should red team their AI models just as they test their networks. OWASP published a machine learning top 10 framework to highlight key AI vulnerabilities. These include data poisoning, model inversion, adversarial inputs, bias, and unauthorized model access. Understanding these helps design resilient, secure ML pipelines. The message is clear. Securing AI is part of securing your organization. Governance is the foundation of trustworthy AI. This means, securing data pipelines, managing model versions, and integrating validation into continuous integration and continuous deployment. MLOps security ensures reproducibility, integrity, and accountability. ISO/IEC 42001, the new AI management standard, provides a framework for this. Think of it as DevSecOps for machine learning. Despite automation, humans remain at the center of security. Analysts validate AI decisions, especially in high-impact cases like account suspension or incident escalation. Human intuition really complements algorithmic detection, ensuring ethical, contextual judgment. Remember, AI doesn't replace cybersecurity professionals, it amplifies them. The next evolution is agentic AI, systems capable of chaining decisions autonomously. Combined with federated threat intelligence, they'll form global adaptive defense grids. However, transparency, accountability, and auditability will determine their success. The future of defense is hybrid, human and machine working in tandem, learning continuously. Well, that's it. This presentation was produced by BlueHat CyberSec Academy for educational purposes. It's intended to inform and inspire professionals to explore AI safely and responsibly. All tools and brand names belong to their respective owners. Remember, technology is only as strong as the ethics guiding its use. Thank you for watching, and continue learning with BlueHat CyberSec Academy, empowering the next generation of cyber defenders.